Check out this chart. Classic 1D stripes at the top, pixel packed 2D matrix codes in the green zone, and some next-level specialized ones down in orange. QR codes steal the spotlight, but each of these has its own superpower. These systems run on patterns of light, binary tricks, radio waves, and decades of smart engineering. Today we go deeper into different flavors of 2D, what 3D really means, and crucially, where they're mostly used in everyday life and industry. Let's dive in. Why did we even need these striped codes? In the 1970s, retail was chaos. Cashiers manually keyed prices, mistakes everywhere, inventory nightmares. Barcodes solved it, giving every product a unique ID, let machines read it fast and accurate. The first scan was a pack of Wrigley's gum in 1974. 1D barcodes. You see them everywhere. On products, packages, tickets. They're simple. Just parallel black bars and white spaces of different widths, holding data only horizontally. Can be read them left to right in one quick linear sweep. Inside, usually just a short number, sometimes a few letters. No long URL, no pictures, just an ID number that looks up the real information. That's why they're so fast and so cheap. How do scanners actually read them? Two main ways. First, the classic laser scanner. A red laser line sweeps across the code, black bars absorb the light, white spaces bounce it back strongly. The scanner times those reflections and instantly turns them into numbers. Second, the modern way. CCD or linear imagers. Think of it like a tiny one-line camera inside your phone or handheld scanner. No moving parts, more reliable, perfect for close-up reading. Both methods convert that pattern of light and dark into digits in just milliseconds. Here are a few types barcodes, each has its strengths and favorite jobs. UPC-A, Universal Product Code, Type A. Usually 12 digits that include company prefix plus item number plus check digit. Mostly used everywhere in US and Canada retail. UPC-E, compressed 6-digit version. This actually squeezes 12 into 6 by dropping zeros, as tiny products need small labels, mostly used in small items like candy and cigarettes, where space is premium. EAN 13, European article number, now international, usually 13 digits, and that 1 digit for prefix for country or company. Mostly used in retail worldwide, like supermarkets and Amazon products. EAN 8, short 8-digit version, for even smaller space, mostly used in tiny products, candies, single cigarettes, small cosmetics. Code 128, high density, full ASCII, numbers, letters, symbols, control charts. Why? Packs more data compactly, mostly used in shipping labels, packaging, logistics, IDs. Interleave 2 of 5, ITF 14, numeric only, mostly used in logistics, warehousing, and shipping, like FedEx and UPS outer boxes. GS1 128, code 128 with GS1 standards, adds application identifiers for extra data like expiry, batch, weight. This turns simple ID into rich info without needing database lookup every time. Mostly used in supply chain and logistics. PharmaCode, numeric only, special error-tolerant design, mostly used in pharmaceutical industry and packaging lines for high-speed verification. All these 1D codes, cheap to print, fast scan, reliable in high-volume spots, like checkout counters or conveyors. 1D was great, but limited data and damage. 2D codes use both dimensions, full grid or pattern, store way more data like text, URLs, and even files. Phone cameras or industrial scanners read the whole thing in one snap. Here are a few types of 2D codes. QR code, the everyday hero. Square grid of modules, combination of black-white squares that's in binary ones and zeros. 3-corner finder eyes, timing lines, alignment patterns for distortion fix. Read Solomon error correction. Up to about 30% damage is okay. Holds thousands of characters. Mostly used in consumer-facing world. Marketing posters, restaurant menus, product packaging, mobile payments, UPI in India, event tickets, social sharing, loyalty programs. Basically anywhere you want to bridge physical to digital very fast. Data matrix. Tiny, super dense square and rectangle with L-shaped solid finder border. High data density and minimal space. Survives approximately 50% damage with strong error correction. Mostly used in industrial and high-precision tracking. Electronics, aerospace parts, pharmaceuticals, medical devices, direct part marking and manufacturing. When space is tiny and reliability is critical, this is the go-to. PDF 417, Stacked rows of mini barcode-like lines from 3 to 90 plus rows, each with start, stop, and row indicators. Stores massive data, up to about 1,800 characters, even signatures or small images. Mostly used in official documents and logistics. Perfect when you need lots of structured info in one scan. Aztec code, central bullseye with spiraling concentric squares, no quiet zone around it. Compact, fast reads, good damage resistance with up to around 23 to 30% error correction. Mostly used in transportation and ticketing. MaxiCode, fixed size hex dot pattern with big central bullseye finder, optimized for speed and odd angles, mostly used in logistics and parcel delivery. UPS packages, high-speed conveyor sorting and shipping hubs, designed for fast machine reads on moving items. Now 3D codes, not holographic sci-fi. They're 2D patterns with actual physical depth, raised, engraved, embossed on the Z-axis, scanned via laser triangulation or 3D imaging. Reads height variations, not just contrast. Why we use them? Extreme durability. Survives paint, chemicals, abrasion, heat, where printed labels die. Mostly used in harsh industrial environments, mostly airplane parts, heavy machinery, medical devices like implants and surgical tools, for sterilization history and recalls, rare in daily life, mostly manufacturing and traceability where permanence beats everything. Bottom row, the ones that ditch paper patterns. NFC tag, small chip plus antenna coil. Phone tap powers it via electromagnetic induction. Sends data over short range, a few centimeters. Mostly used in contactless everything. Payments, Google Pay, Apple Pay, transit cards, access control, device pairing like Bluetooth speakers, smart posters or tags for quick info. RFID tag, similar but longer range from inches to meters, mostly used for tracking at scale, supply chain, inventory warehouses, toll booths, animal or livestock ID. Apple app clip code, circular marker QR-like with center icon, sometimes NFC hybrid. Scanning or taping, launches lightweight app mini version instantly without full install. Mostly used in quick experiences, rent scooters and bikes, order food at tables, parking payments, business promotions and event check-ins. Apple's way to make try before download seamless. From consumer QR magic to industrial data matrix toughness, transport Aztec tickets, invisible NFC taps, and rugged 3D engravings. Each code evolved for its niche. More data, better survival, faster reads, or zero effort. They're quietly powering retail, factories, airports, hospitals, and your daily taps. Next scan you do, you'll spot the scanner's family tree. If this helped you see the barcode world differently, subscribe, share your craziest code encounter in comments. What's the weirdest place you've spotted one? Thanks for watching.